All right, so today we're looking at random numbers, and we're also going to be taking a look at how we might use this in future projects. Let me bring up this slide here. Now, typically when you're doing a simulation, simulations are really good to use, it's really good to use computers to do simulations. Say you're simulating the orbits of planets around a star, or say you're trying to simulate how organisms grow inside of a petri dish in science class, and you have the equations of how these things grow or how things orbit. You can use random number generators to generate random events that would maybe perturb these systems, and then see how these systems react to these perturbations. So I really like generating random numbers because it allows you to kind of see what happens to a system when random elements occur. So we've used the random number generator already a little bit, but the way it works is the random number generator is created using just a standard call to the constructor. The class is called random, so capital random, and then you can call it anything you want. I usually call it rand, you can call it generator, and you say new random. Now the key point here is to remember that you only want one random number generator per program, okay? Even though you're generating lots of different random numbers in different settings, you want your random number generator to be something called a singleton. You don't want more than one in your program. The reason for that is if you generate another random number generator, it will most likely, if it gets the same seed, generate the same sequence of random numbers. And then your numbers aren't going to be random. They're going to be predictable. So the key thing here to remember is if you do include a random number generator in your program, make sure there's only one. And I'm talking not just in your class, but in the entire program. There should be only one random number generator in general. Now, we've tried this next one, right? When we were generating random rectangles all over our screens, we would ask the generator for the next int. And next int is a little bit strange in that the range of numbers that it returns, well, first of all, it returns integers, which are whole numbers. But say if you said next int 10, you would never actually get the value of 10. Because notice the range it gives you. It goes from 0, less than or equal to n, less than or equal to the limit that you give it. Did I say less than or equal? I mean less than, okay? It doesn't include a. So if I say I want 10 numbers, it will give you 10 random numbers. They're just going to be numbered from 0 to 9. Notice how it always starts with a 0 and ends with a 9. Now you can always adjust this. Say you wanted the numbers 1 through 10. Well, all you have to do is just add 1 to the output from this function, and then you get the numbers 1 through 10. Okay? So there's ways to adjust this. But the next one is even stranger. Is when you use the random number generator to generate a double. And in this case, it's going to generate a number between 0 and almost 1. And then the question you have to ask yourself is, well, what good is that? Say I want to generate numbers between 0 and 75.25. Say that's my range. How might I do that using next double? Because next double only returns you numbers between 0 and almost 1, but not quite 1. Yeah, you could maybe do that, but again, if you want that 0.75, that 0.75 or 75.25, that 0.25 is going to get chopped off. Okay, so I'm going to show you how you use this. Basically, when you call next double, Next double doesn't give you really a random number. What it gives you is a random scaling factor. Okay? You take the number and you multiply it times the range that you want. And then you'll get a number between 0 and the number you want. Okay? Or almost the number you want. Again, it's not inclusive when it comes to the final thing. So if you wanted to throw a 6-sided die, again, I told you that, well, we want the numbers 1 through 6, not 0 through 5, right? And we're going to be creating a die class. So if we have a 6-sided die, we say, okay, I want to roll this integer. I'm going to take whatever I roll with the generator. I say next int 6. A novice programmer would think, okay, I'll get the numbers 1 to 6. Not true. You get the numbers 0 through 5. To adjust it so it matches up with a regular die, then you add 1 to it. And then you get the numbers 1 through 6. So realize when you say 6, you're not going to get a 6. Very frustrating. You're going to get 0 through 5. Okay, so here's our die class. Basically, it has its own internal random number generator. It has a number of sides. In its constructor, it creates a new random number generator right here in the constructor. So that means each die you create is going to have its own random number generator. And that kind of breaks my rule. Remember, my rule is you should only have one random number generator per program. This is going to have one random number generator per die, which is not a good idea in the long run. So we're going to change this one around when we code it up ourselves. Okay, but the general idea is here. And then when you roll the die, here they call it cast the die. I stay away from the word cast because we use that already, kind of, when we're casting an integer to a double and inside. I'm reluctant to use the word cast. Now, when you're casting from an integer to a double, there's an E at the end of the word cast, C-A-S-T-E, but still, I'd rather use the word roll. And then here, you roll the die, and you get, say it's a 4-sided die, you'll get the numbers between 0 and 3, and you add 1 to it. And then you return that value as the value of the method cast, and now you just roll the die. You generated a random number. After we create our die, we're also going to create a set of dice. We just call it dice. And you can say how many dice you want in your set of dice, so that you say, I'm going to roll 3 dice at the same time. And you roll them. Or if you're in Vegas, you're rolling 2 dice. Or if you're playing Yahtzee, you're rolling 5 dice. You know, there's all these dice games. So we're going to create 2 types of classes here, a die class and a dice class. Here's the simulator. Here's our main method. We created a new die. We make it have 6 sides. That's its construction parameter. We create a constant called tries. So we're going to roll the dice 10 times. So we're going from 1 to 10. We cast the die and we print out what we got once we rolled it. And that's all on the same line. So see, we use system.out.print, not print line. So it will stay on the same line. So that forces us to put a blank between them. Okay? If there were print lines, we wouldn't need to put that blank there. And then once we're done rolling all 10, then we'll go out to the next line. Okay? So let's try to create our own die class today. What we're going to do is change this around a little bit, change some of the wording, just so it matches up a little bit better with what I think a real die class should look like. And then we'll create a simulator like this to give it a try. Okay? I won't tell you what the output is. We'll actually code it up and find out. Oops. Okay, so let's right now we're going to just do it with text, but then eventually we're going to have to draw these die. When we roll it, we say, oh, I got a 3. Okay, now I got to draw a 3. say it's a 6-sided dice, so you draw a square, and then you got to draw 3 circles in the right places, like you'd normally see on a 6-sided die. That gets a little bit harder. Right? Okay, so if you could open up a new project, and we're going to call this project, let's just call it Dice. Okay? So a new project, and we'll call it the Dice class, or the Dice project. Well, we're gonna have a class called Dice, so maybe that wasn't the best choice. Or I guess maybe call it Dice Simulator. I think that's what I called it in the videos before. So let's just so that they match it with the videos, let's just make sure we call it Dice Simulator. So we're renaming things. We'll also rename this class. Okay. So I'll go into the class I created. We'll save that. It complains. So you left click here and say rename file to dicesimulator.java. It does that. And then also this package, should we call it Dice? Yeah, let's just leave the package name as Dice, okay? Okay, so the way we have the project set up, the project's called Dice Simulator. It's got a class in it called Dice Simulator, and this is just our test class. This is where our main method is. This is just going to exercise our die class and our dice class once we get them written. And so we call it Dice Simulator, and we'll leave our package name as Dice. Has everybody got that? I know that was a little confusing, but I got all the names right. Okay, so the next thing I'd like to try is to create the die class. This is the single die, you know. So we right click on our package name and we say new Java class. This time it won't create a main method, and we're just going to call it die. We finish. Pretty simple. It puts the package names in there. It gives us the class structure, and that's about it. And the rest is up to us. All right, so the first thing I do when it comes to the dice class is, or the die class, is I decide, well, what do I need to be able to do with it? And the two things I need to be able to do with the die is I need to be able to create a die, and I need to be able to roll the die. And that's about it. So first let's look at the creation of the die. And the way we create something is we build a constructor. Okay, so you want all your constructor to be public, typically. Public, remember, constructors don't return anything. They do, but they just don't return anything explicit. Hey, okay. So public die, and then what are we going to need to know? Well, first, we want this to be a generic die class, so we want to be able to vary the number of sides it has. Okay. So we're going to call that first one num sides. But I also mentioned that in any program, you typically only want one random number generator. You don't want more than one. So we're going to actually, instead of creating a random number generator inside the die, we'll have a random number generator passed in as a construction parameter. Okay. So we would say random, and we can just call it rand. Okay. Now we get some complaints because it doesn't know what random is, what that class is, right? So what do we have to do to get it so it understands what that class name is? Anybody know? Yeah.
Create a random class.
We have to create our own random class, or another option would be to import a pre-existing random class from the Java library. So we're going to choose that second option, okay, because it already exists. So I always say, why reinvent the wheel? If it's already there, let's use the wheel that's there rather than create a new one. So we'll import that. And see how it added that import up here? Okay, so now we have the structure, at least for our die. Now, the other thing we want to do is we want to be able to roll the die. So that would be our other method. Now, when we roll the die, it would be nice to know what we rolled. So that's going to be our return value. We're going to assume that our die return whole numbers. Okay, we're not going to create dice that return numbers like 7.295 or something. That'd be a weird set of dice. And then we're just going to call our method roll. Does it require any parameters? Not really. We just roll the die. Okay. Now this thing complains because I just said that roll is going to return an integer, but it doesn't return an integer yet. So it's going to complain until we fill that in, but we'll just let it complain until we get there. So now we have our structure. Then the next question is, okay, we know what we need to do. Those are our verbs. We need to be able to create a die using a constructor. We need to be able to roll the die. So we know what we need to do. Now the question is, how are we going to do this? In order to roll the die, right, we're going to have to know how many sides it has to call the random number generator, right? We would say, well, we could create an integer called value. And then this is the number that we roll. And we could say, well, we're going to roll the die. So the way you roll the die or use the random number generator is you say ran dot. It didn't help us out. Why not? Yeah, I know why not. Okay. Because there's a couple things we didn't store. We say ran dot next int, and then next int, the question is, well, what's the range of numbers we want to get? Well, we want from 0, or actually 1, to the number of sides, right? Because we could have a 4-sided die, we could have an 8-sided die, we could have a 6-sided die. We're trying to make this die generic. So what you would say here is num sides, right? And then we'd add 1 to it. Because if we say a 4-sided die, well, remember that next int returns the numbers 0 through 3. And we want the numbers 1 through 4. So we're going to add 1 to it to just shift the range from 0 to 3 to 1 to 4. See how we did that? But we've got two problems. And then here we return value. But we have a couple problems. It doesn't know what rand is. It doesn't know what num size is. And the question is, well, why doesn't it know that? I mean, we've got it right here. See, there's num sides, there's random. Why doesn't it know what those things are down here? Yeah, we haven't created the random number generator. We're assuming here that the random number generator gets created outside of the class. Okay. But well, up here in the constructor, did we store those things anywhere? If we don't store them anywhere, we can't use them down here. This is a separate method, right? These parameters coming in aren't available. They're inside this method, and they're down here. These, in this method, these names mean nothing. because they only exist as construction parameters. And we didn't store those construction parameters in any instance variables, right? You remember an object has to have instance variables, or can have instance variables to remember stuff? What's the point of having instance variables? Well, it's so that other methods in your class can actually use them, okay? But we didn't store them anywhere, nor did we create those instance variables. So let's do that now. Let's create a few instance variables down here. Well, the first instance variable we need would be the number of sides, right? So now our die is going to be able to remember how many sides it has, okay? Because it has that inside of it. Now it has that as a piece of data inside of that object. Notice as soon as we do that, our little squiggly line disappears right there. Because we added an instance variable, we have to go up to the constructor. One of the responsibilities of the constructor is to initialize the instance variables. So we say this dot numsides I could type. We should be used to this idiom by now, where see how this a construction parameter coming in has the same name as the instance variables. So in order to differentiate the two, we say, okay, take the one that comes in as a parameter and store it into this object's num side, so this one down here. So even though they have the same name, you're able to separate them because we use the keyword this. Okay? So make sure to include the keyword this. You only need to include the keyword this is if they have the same name. If the construction parameter and the instance variable have the same name, then you need to include the keyword this. If they don't, then you don't need to include the keyword this. Okay? Because there's no need to differentiate because they had two different names. But in this case, they have the same name. The other thing we need to store is the random number generator. Now, as I was saying earlier, we're going to assume this random generator is already created. We're just going to be using it inside this die class. We need to store that somewhere as well. So we'll say private random, because that's its type. And we'll also call it rand. Because we added a new instance variable, again, one of the responsibilities of the constructor is to initialize that instance variable. So we're going to give it the value of rand. Okay, so we have this die. We're able to roll it now. We generate this value, but I can see instances where in a lot of the games that we're going to create, where we roll the die, we do a bunch of other stuff, and then we want to come back and say, okay, what did I roll? What was that? I rolled like 10 minutes ago. I have the die right here. I'll just ask it what I rolled. Well, you can't ask it because it didn't store that anywhere. The value is only in the roll method. So once you roll it and you get that number back, the die has no clue what it just rolled. It forgets it, right? Because we didn't store it anywhere. So it might be nice is if we can make our die a little bit smarter in that it can remember what was the last number it rolled, so that we can come back to it later and say, hey, what did you roll last time? It'll say, oh, I rolled a 5. Oh, thanks. Okay. So what I'm suggesting here then is, let's not make value a local variable that gets forgotten right at the end of this method. Let's also promote that to be an instance variable. So here's another one, private int value. And we get a warning right here. It says local variable hides a field. These instance variables are also called fields. And that's usually a bad thing. Okay, that means when you set the value in here, it's not going to set the value down here. And we don't want that. So what we do is we delete this line of code. See how value turned green? Right here, it turned green. That's telling you, hey, that's an instance variable now. So when we roll it, it's going to remember that value. So that later on when we come back and ask it, hey, what value did you roll? It can respond and say, oh, I rolled a 4, or I rolled a 2. It'll remember what it rolled last time. Okay, so we built this die class now. It can remember what it rolled. It relies on an external random number generator because we only want to have one random number generator per program. So we'll let the program create the random number generator rather than the die. It knows how many sides it has. Say we want to come back and ask the die what we rolled. How do we do that? Is there a way to do that right now? We've created our die, we rolled it, we stored our value. Geez, is there a way to ask it what we rolled? Yeah, get value. Okay, we don't have a get value function. So now we have to think about accessors and mutators for these things we have in here. Okay. Do we want to give the ability to change the number of sides after we create the die? Does that make sense? Do you want to set num sides or set sides kind of thing? Does that make sense? I don't know. How about getting the number of sides? Say we want to ask a die how many sides it has. Would we do that? Would you imagine doing that? Yeah, probably so. What about the random number generator? Well, we passed it in. We didn't create it inside this die. So it's accessible outside in the main program. So we probably don't need to get that, and nor do we want to reset it. So that one wouldn't get an accessor and mutator. What about the value? Do we want to get the value? Yeah, we do. After we roll it and we go away, we'll go away for a while, come back, and then ask it, okay, what did we roll? That's a good one. Do we want to set the value? Well, sneakily, we already have a set value function. It's just not called set value. What's it called? What was that? Yeah, it's called roll. That's how you set the value. So you roll it. Okay. So it already has a mutator. It just doesn't have the word set in it. Okay? So let's generate those accessor and mutators we talked about. And for things that are iffy, like do we want it to change the number of sides, we can always come back later and add the set number of sides. But I think we want to get it. We don't necessarily want to set it. So we go to the Refactor menu. Remember this? We say Refactor, because we don't want to type all these in. We say encapsulate fields. And this time, instead of just selecting everything, we have to be more, well, selective, right? Do we want to get the number of sides? Yeah, that makes sense. Do we want to set the number of sides? We're kind of on the fence on that one. So we're going to wait until we have a need for that. I can't think of a need for that right now, but we'll leave that one unchecked. Do we need to get the random number generator or set it? The answer is probably not, since it's available from the outside of the class. Do we need to be able to get the value? Yeah. Do we need to be able to set the value? The answer is, well, we already can set the value. We just roll the dice, right? You shouldn't be able to go in there and set a specific value on a die. That's cheating, right? Unless you want to make cheating dice. Yahtzee every time, yes. Okay. So we're not going to make cheating dice or loaded dice. Okay, so we're not going to have a set value. So we're only going to generate a get num sides and a get value, those two. Okay. We click on Refactor, and it adds get num sides and get value. Woohoo! Well, let's see. Num sides, when they pass it in, say if it's a 6-sided die, they're going to pass in 6. Notice that we adjust for that when we roll it. So when we say get num sides, I think we still want to just get 6 coming back, because we adjust for that in the roll. I think that's the only place where we have to adjust, but that's a good question. Okay. So given the lame-o die class they had in the book, I think this one's a little bit better. Of course, I'm biased. This gives us a little bit more robustness. It's able to remember its value. It's able to not generate a random number for every, or random number generator for every die, which is a no-no, which breaks a few rules. So I think, for example, this is probably a good die class. But how do we know it's any good unless we try it, right? So let's try it and see if we get what we want. Okay, so we're going to create a loop just like we had in our example, but we're going to be using our die class rather than one from the book, right? First thing we want to do is, well, let's create that random number generator. Remember, it's a construction parameter, so we're going to need it. So we would say random ran equals new random. Of course, as soon as we do that, it wants us to import the random class. So once you type that in, add in the import to that. So we have a random number generator. They also had a constant that say how many times we're going to roll the die. So we'll say final int. I think they called it tries. How many times are we going to try? And it sets it, and they set it equal to 10. So we're going to roll it 10 times. We can change it, but it's a constant, right? If we want to roll it 1,000 times, we can. 1,000,000 times. Doesn't matter. This is just for testing. Okay, so other thing we need to do is we need to create a die, right? We haven't done that yet. So let's do that. So we say die. I usually just say my die, so you know that's a name that I come up with. Equals new die. And then die takes certain construction parameters. The first being the number of sides. So say we'll use a magic number 6, 6-sided die. And then we have to pass in the random number generator, right? Because that's the other construction parameter. If we go back to our die class, you see that the constructor takes the number of sides and then a reference to the random number generator. So we just type in rand. Okay. Now, does that actually roll the die? And the answer is no, it just creates the die and gets it ready to roll. Okay, so now we're ready to roll. Hey. Mr. V and his bad puns. Okay. So now we have our setup. So now we want to roll it 10 times. If we want to do something over and over again, what do we need? A loop, okay? We know how many times we want to roll it, right? 10 times, or number of tries at least. So is it better to use a for loop or a while loop? For you use if you know exactly how many times you're going to roll it. That's one of the good reasons for using a for loop. So let's use a for loop. That's what they're for. Oh, tears. My jokes get worse the earlier in the morning they are. I'm one of those people who like to start counting at 0. I'm a programmer. I don't like to go from 1 to 10. I like to go from 0 to 9. just because that simplifies things later on. So even though the book says 1 to 10, I'm going to say 0 to 9. How can it go from 0 to 9? Well, we can say I less than 10. Notice it's not going to include 10, but since we're in we didn't say less than or equal to 10, because that will give us 11 tries, right? So if you want to do something 10 times, I would write your for loop this way. Start counting at 0, make the limit 10. The word 10 is still there, or the number 10 is still there. Just don't use less than or equal to in the condition. Just use less than. Okay? And then we just add 1 to I at the bottom of the loop. Oops. Okay? Well, actually, we shouldn't use 10. We should use tries, right? We created this constant, and then we forgot to use it. Okay. So now we know what 10 means. Okay. Oh, 10 means the number of tries. It's not just some number grabbed out of the air. So then they suggested to do system.out.print. And then here we could, since our method returns a value, we can just embed our method right there in the print statement. Okay? Any method that returns a value, you can substitute for a variable or a literal. So you could just say myDie.roll. So you roll the die. That's going to return a number, the number it rolled, right? And then, because we don't want to do any number conversions, we append a space to the end. And that will automatically convert that integer into a string and paste a space next to it. Notice we didn't say print line, we said print. So we're going to see our numbers all on the same line. If we said print line, it would go from one line to the next. We do want to eventually finish off the line. So after we get outside the loop, we could say system.out.println. And pass in nothing. Basically, that just ends the line. Right? It prints a blank line, basically. Or not a blank line. It'll just print an end of line character and make us move to the next line. Okay? So we printed 10 numbers, or however many tries that we've done, and then it will advance us to the next line. Okay, so we've got our loop. We're rolling the dice 10 times. Let's see what kind of distribution we get when we roll it. Here's our output: 3, 4, 4, 4, 5, 4, 3, 1, 1, 1. Suspect. What's wrong with that? There's 2 numbers missing. 6 and 2. We better run it again to make sure we get 6s and 2s. I'm not convinced that this is working right. Oh, there's a 2, there's a 6. So we just had bad luck the first time, right? And you can keep doing this, and you'll find you'll get numbers between 1 and 6, which is what we hoped, right? Now let's change this around a little bit and say, okay, I want to do 8-sided die. So I changed the number of sides to 8. What would an 8-sided die look like? Okay. Okay, so the expectation here is when we change the number of sides to 8, we should get numbers from 1 to 8, right? Let's see if that's what we get. Well, we didn't get 8. Oh, there's an 8. There's no 1, though. There's no 4. There's a 4. There's a 7. There's a 1. Okay? So we didn't limit ourselves to just 6-sided dice. By being a little bit more creative and a little bit more flexible, we created a die that could have any number of sides. Okay, let's do silly things. 1-sided die. I wonder what we're going to get. Any guesses? All ones, yeah. Hey, I just rolled a 1. Woohoo! 0-sided die. Oh, I don't know what's going to happen there. Clunk, yeah. We didn't put any code in there for stupid human tricks, right? It crashes. Okay. Nope. So you can play around with this stuff. I'm going to change it back to 6 so it'll work. That's our first step when it comes to creating our dice simulator.